Okay, everyone, today we're gonna do the Paragon X electromagnetism class. Today will be our fifth EM class, and we're gonna be talking about Faraday's law and Ampere's law. So let's first go over the homework from last week. Let there be a particle with charge Q and mass m traveling perpendicularly to a uniform magnetic field B with speed v. Given that it is exhibiting circular motion, find the radius of the circular motion and find the angular velocity of the circular motion. Okay, so this problem really ties into what we learned about magnetism last class and also some mechanics principles. So let's draw a picture. So we have a charge Q and it's moving, let's say it's moving to the right with speed v. Now there's going to be a uniform magnetic field B. Let's say it's pointing upwards. So this will be my magnetic field B. And then I know that is exhibiting circular motion. Now remember last class when we learned it's called the Lorentz force. So it's like if I have a charge and it's moving in a magnetic field, the force the charge experiences, which will be F, right? That will be Q times velocity vector cross the magnetic field vector. Okay, so if we look at it, right, um, I know that the magnetic field B is perpendicular to the velocity V. So in this case, the force would just be Q V times the B. And I also know that the particle is going under circular motion. And remember that back in the mechanics days when we had uh, a particle and it has a mass m and it's doing circular motion, then the centripetal force needed for like it to have circular motion would be, well, FCP. It will equal to the m v squared divided by the r. Okay, so if you use that in our case, QVB equals to the m v squared divided by the r. So what we'll get is after you cancel the v, um, you're going to get R equals to MV divided by QB, and that will be our answer for part A, the radius of the circular motion. Now, if we want to find the angular velocity of the circular motion, we'll remember that we have V equals to omega times R. We found R already. We also know what V is. So then omega would just be V divided by R, and we'll find that it will equal to QB divided by the m. Okay, so that's our answer to part B. This is our answer to part A. All right, so this problem really tested what we learned last class about the uh magnetic force and also some principles you should know in mechanics. All right, let's go on to the next problem. All right, let there be a conducting circular ring, a radius r carrying a steady current. Write the integral for the magnetic field, a height h above the center of the wire. Okay, so let's draw a diagram here. All right, so here's our conducting circular ring. Okay, we can just say it's like a circular wire loop. And then I look at the magnetic field at this point over here, and it's a height h above the center of the wire. So that will be height h. Okay, and I also know that the circular ring has a radius of r. Now I want to find the magnetic field at height h above the center of the wire. Okay, so remember that we had the Biot-Savart law.